Hello, my name is Barsh, and we are talking about computer networks and how they are organized. And we mentioned in one short first three, let's say, layers that are of the interest in some devices. Of course, there is a PHY layer or physical layer. Second one is a MAC layer or data link layer with MAC address inside that device, which is considering MAC layer. And then we have also third or IP layer or network layer, which is considering IP addresses. Another one is, let's say, transport layer, which is usual protocol is TCP. And then we have application layer, but they are not mentioned here. We are discussing these basic interfaces, which are somehow organized in the device chips and or another way. Uh, we will talk later about physical layer, but now we will consider MAC layer and MAC addresses. And we see that MAC layer have network interface controller and its unique identifier. So for manipulation in the MAC layer, we have a network interface controller, which feature is to have a unique identifier or MAC address, which is integrated part of that network interface controller or NIC. And that NIC can be a standalone controller or can be part of the microcontroller or system on chip, which is visible here in this this section. NIC or network interface controller. So microcontrollers can have their own Ethernet or another, let's say, Mac controller, which can manage on that level, which can manage transfer of data uh, to the device or from the device. And also system on chip also have inside of them integrated some kind of network interface or controller, which is manipulating and in charge of transferring data inside or outside the system of chip. And it can be a standard way like Ethernet, Wi-Fi, or other things which can transfer data in this, let's say, computer networks manner. And yeah, first thing that we discuss is MAC layer. We define what is network interface controller, that it have a unique identifier or MAC address, and how that MAC address is organized we will see in next slide. As you can see in next slide, what is MAC? MAC is media access control. So this is, let's say, some controller usually in some device, some chip, either NIC, either microcontroller, either system on chip, which have some controller which is control actually transfer of data from and inside some device, which we mentioned. So NIC, microcontroller or system on chip or something else. But the important thing that that device which can use MAC or media access control actually must have some kind of MAC controller which is inside the integrated part of that device. All that controllers have unique address which is called MAC address, and as it says here, is a unique identifier of network interface or controller, network interface controller, given in hexadecimal format. So these MAC addresses are actually in hexadecimal format. So the representation of these MAC addresses is hexadecimal format, which means it takes 4 bits for every and each hexadecimal number. And here we can see how it's organized. MAC address format have 48 bits in form of 6 times 8 bits, so 6 times 8 bytes actually, in hexadecimal format. Example of that is given here, or for the Cisco style, it's given here. What we can see is that we have two hexadecimal numbers which actually make 1 byte. So 4 for this number, hexadecimal number, 4 bits for this hexadecimal number, and then we have separation in this way, or for Cisco it's given this way. And there is actually here is clearly visible that we have 6 bytes. 4 and 4 total 8, 4 and 4 total 8, 4 and 4 bits total 8 bits or byte, and so on and so on. So 6 bytes is enough to have or assign this MAC address for specific device, which have that possibility of controlling communication with this network interface controller. So you inside the device or standalone device, you must have this network interface controller, which is in charge for deciding if in package he recognize his MAC address, is he managing that? Is he managing this package or not, and where to transfer, either to take the data or not. And we will see later for IP addresses how it's going, but this is on the for the device and its controller or MAC controller. This is how things going on, and this is address. This MAC address is, let's say, is specific for a specific device, and we will see how it's specific. So first 24 bits or 3 bytes, so it means like in this example, like these 3 bytes. OE, organizationally unique identifier, I assign to network controller manufacturer. So some standard or some commission probably is assigning first 3 bytes for specific manufacturer of these controllers. Assign specific 3 byte number for that specific manufacturer. So that commission probably is giving NICs, microcontroller, and system on chip manufacturers, giving these the first 3 bytes for specific recognition. To make clear separation between devices which are using this layer of, let's say, control of data flow and the recognition of addresses. Then last 24 bytes or last 3 bytes, which is given here, they representing unique number which manufacturer assigned to device. That means that if this is given to the manufacturer, these 3 bytes are given from the manufacturer for its specific device. He assigned these addresses to its device. So this part of the address is assigned or dedicated to the controller by its manufacturer. So once again, we have 3 bytes from some higher institution which is assigning to the manufacturers these first 3 bytes of address, and this is what specific manufacturer gives to its device. And in complete and total, this is total, let's say, address, MAC address of device which are using on the data link layer or layer 2. Then we have this. So it's need to say that on one let's say chip there can be one or maybe two or more network interfaces. So if computer have more network interfaces like Ethernet ports and Wi-Fi cards and so on, every one of them have its own MAC address. So here I give examples. So let's say you have one or two or more on your PCB, two NICs or network interface controllers. Every one of them have its own specific MAC address. So as we said, where is the NIC address? Where is the NIC controller? There is address assigned to him. Also, if one, for example, one microcontroller have, let's say, Ethernet protocol in it, or possibility to use Ethernet or any kind of another network communication, which is in this scope, let's say like Ethernet, then it must have a network interface controller or NIC. And in many cases there is not just one but two or more network interface controllers which is in charge of data flow inside and outside from the chip or device or microcontroller. So beside of this, let's say in some controllers, microcontrollers, there is more than one network interface controller, and in some examples like NVIDIA system on chip, we mentioned that we have, let's say, GBA, one GBA controller and four MGBA or multi-gigabit Ethernet controllers. So there, on one system on chip, there can be one, two, or in that example, five in total network interface controllers, and every one of them has its own MAC addresses, which is representing like specific authentication or identification of exact the device according to what we said here in this tile where we talking about how MAC address is assigned to any kind of the device. So system on chip manufacturer can decide how many network controllers it wants to have, and manufacture those controllers inside system on chip or microcontroller, and also according to this it assigns specific MAC address for this device integrated in system on chip or microcontroller. So I hope that we explain how it works, and usually there is a lot of confusion about this topic, about what is MAC, what is NIC, what is MAC address, and why we mentioning MAC address when we have IP address, and that's not the same. So I hope this help to people to, let's say, distinguish those two things, and we will later talk about IP addresses and that network layer. And this was as we said, data link layer. Maybe I somewhere said the dial-up, but that was a mistake. It's a data link layer. So this will be all for this this video, and hope we see each other soon.